worksheet 2. So moving to the first question, children, the pressure inside a liquid of density D at a depth H below its surface is given as. So what are the given data, children? Density is given as D, depth is given as H. Then you are asked to find the pressure. So what is the formula for pressure? Pressure at a given depth H is given by H. If density is D, then pressure at a given depth H is given as HdG. And hence the correct option is second option, that is HdG. So let us have a look at the second question. Pressure at any point inside a liquid is. So as just now we have discussed the formula for pressure as HdG. So pressure is directly proportional to the depth of the fluid. Pressure is directly proportional to the density of the fluid, and pressure also depends upon the acceleration due to gravity. So here directly inversely proportional to the, they have only focused on the density, square root of density. So inversely is a wrong option. So the only correct option is directly. So directly proportional to the density or directly proportional to the square root of density. It's not square root. The only correct option here is pressure at a point inside a liquid is directly proportional to the density of the liquid. Hence first option is true. Okay, so inversely is false, square root of density is also false statement. So moving to the next question, children, third one. As the depth of a liquid increases, the pressure of a liquid, what happens? Just now we have discussed that P is equals to HdG. So this implies that pressure is directly proportional to the depth of the fluid. So when depth of the fluid increases, the pressure also increases accordingly. So as the depth of a liquid increases, the pressure of a liquid also increases, and hence the second option is true. Moving ahead with the fourth question. Liquid exerts pressure. In which direction, children? Very beginning of the class we have discussed three types of pressure. One is downward pressure, other is upward pressure, and third one is lateral pressure. So how many types of pressures are considered? Three types. So that is downward pressure, upward pressure, as well as lateral pressure. So all directions the pressure is possible, and hence the correct option is liquid exerts pressure in all directions, downward, upward and sideways. Downward, upward and sideways. So that means all directions. So now have a look at the fifth question. Liquid pressure at a point in a liquid does not depend on. Does it depend on density? So pressure of a liquid depends on density of the liquid? Yes. So but you are asking does not depend on. Actually it depends on density. Shape of the vessel, does it depend on shape? Pressure of a liquid does not depend upon, independent of area of cross section and shape of the container. So this is the wrong one. So this does not depend upon the shape of the container. Does it depend on the depth of the? Yes. Acceleration due to gravity? Yes, depends on density, depth as well as acceleration due to gravity. So on what factor does not depend on? It does not depend upon the shape of the vessel, and hence the second statement is the answer. So now moving to the sixth question. If the density of a liquid increases, the pressure at a point inside the liquid at a given depth, what happens? So what is increasing? Density is increasing. As we know that pressure is equals to HdG. So pressure is directly proportional to density. So as and when the density of the liquid increases, pressure also increases. So the density of a liquid increases, the pressure at a point, the liquid at a depth, what happens? Okay, the pressure, okay, point in the liquid at a given depth, pressure also increases as density increases, and hence third option is true. So look at the seventh question, children. Standing liquids. What are standing liquids? I earlier told you that static, rest condition or stationary liquids. exerts pressure on the bottom due to its own mass, weight, both the mass and weight or none of the above. So, the downward direction, what we have calculated force, the normal force acting in the downward direction. That normal force is also called as thrust, and that thrust is given by F is equals to mg. But what is mg, children? Mg is nothing but weight. Okay. So, pressure on the bottom is due to its own weight. The correct option is option 2, weight. So, eighth one. Sideways pressure. Sideways, other name of sideways is lateral pressure. Sideways pressure exerted by a liquid is called as your, is it lateral, upward, downward or none of this? Lateral pressure. So, first option is true. Okay, children. Ninth one. Pressure in a fluid is independent of, earlier we have discussed that pressure in a fluid is independent of two factors. One is area of cross section and the other is shape of the container. So, height, no, it depends on height. Density, it also depends on density. Area of cross section, yes. So, pressure of a liquid is independent on area of cross section, but it depends on height or depth as well as density of the liquid. So, for this, which one will will be the correct option? Third option. So, now 10th question. These are statement problems, children. First statement, pressure exerted by the liquid depends upon the depth of the liquid. Very true. Pressure P is equals to H D G. So, pressure depends upon the depth of the liquid. First statement is true. Statement B, pressure exerted by the liquid depends upon acceleration due to gravity. So, this also indicates that pressure also depends upon acceleration due to gravity. Even the second statement is also true. So, what was our observation? Both the statements are true. So, where is the correct one? Both statements are true. So, the correct option is option 2. Clear, children? Okay. So, now have a look at the 11th question. Pressure at a certain depth in river water is P1 and at the same depth in sea water it is P2. Okay. So, think carefully, children, try to understand this. Pressure at a certain depth in river water is P1 and at the same depth H is constant. Sea water it is given as P2. Then bracket it was given density of sea water is greater than that of the river water. So, first of all let us write the given data. Given that density of sea water is greater than that of the density of river water. This is the given statement. Density of sea water is greater than the density of river water. What else was given? Pressure at a certain depth in a river water. Pressure in river water, it is taken as P1, whereas sea water it is taken as P2. You agree, children? Then you need to identify the relation between P1 and P2. What is the formula for P, children? As we know that pressure is equals to HdG. Both cases it was given that H is constant. Same depth. They gave it as same depth. So, H is same for both. Acceleration due to gravity at a given height or depth is same. So, what is changing? Density of the liquid is changing. So, clearly we know that as pressure is directly proportional to density of the liquid. So, if density increases, pressure also increases. If density is low, pressure also low. From this, we concluded that density of sea water is greater than density of river water. If density is larger, pressure will be larger. So, clearly pressure of sea water, that is P2, because density of sea is directly related to pressure at sea. So, density at sea means pressure at sea is indicated by P2. is greater than of 1. Okay, so P2 is greater than P1. But here they have compared P1. You can also write in the reversals. If P2 is greater than P1, we can conclude that P1 is less than P2. Both are same. P2 is greater than P1 or P1 is less than P2. So which one is the correct option, children? Third option. I hope you understood. Because density is pressure directly depends upon density. Larger the density, larger will be pressure. Lesser the density, lesser will be pressure. So since P2 is greater than P1, we can also conclude that P1 is less than P2. Hence, the third option is true.